Welcome back to another episode of Agentic AI, the future of intelligent systems. I'm your host, Navveen Balani. And in this episode, I want to talk about something we don't usually associate with intelligence. Not models, not agents, not reasoning, infrastructure. Because as we build agentic AI systems that can reason, plan, use tools, collaborate with other agents, and operate continuously, there is a physical question underneath all of that intelligence. What does intelligence actually take from the place where it runs? We spend a lot of time talking about how intelligent AI is becoming, but perhaps we don't spend enough time talking about the physical infrastructure required to make that intelligence possible. A data center, at its simplest, is a warehouse full of computers. Those computers consume electricity, they generate heat, and that heat has to go somewhere. Cooling that infrastructure takes resources, often electricity, and in many designs, water. Now scale that up to the new generation of AI campuses. These aren't simply slightly larger versions of yesterday's data centers. We're talking about enormous concentrations of compute with electricity requirements that can rival those of a mid sized city and significant demands for cooling and water. And unlike a city, these systems don't necessarily slow down at night. Training continues, inference continues, applications continue, and increasingly, agents continue working. An agent can receive a goal, reason about it, call several tools, invoke another model, retrieve information, evaluate the result, and continue working. Multiply that across millions of agents and billions of interactions, and the physical infrastructure underneath intelligence becomes a very different problem. And here's the question I think we need to start asking. Before we build the infrastructure for AI, do we actually know what that infrastructure will take from the place where we build it? Today, the answer isn't always clear. A project can have its land allocated, its investment incentives negotiated, its power requirements planned, and construction underway, while some of the most important questions about water, grid impact, or community infrastructure are still being worked out. How much water will the facility use? Where will that water come from? What happens during a drought? How much electricity will it require? Who pays for the grid upgrades? Can the facility reduce its demand when the grid is under stress? What happens to the community around it? These aren't futuristic questions, they're basic infrastructure questions. And this isn't about blaming companies or governments. The demand is real. Compute is becoming infrastructure. Governments want investment, communities want jobs, companies need capacity, society wants the benefits that AI can deliver. Many operators are also investing heavily in more efficient cooling, renewable energy, and water recycling. So the answer isn't simply to say don't build AI infrastructure. The answer is to make sure we understand the terms of the build. And that's where I think we need a new idea, an AI siting ledger, a shared 8-question contract for major AI infrastructure projects. The idea is simple. Before a major AI campus is approved, there should be a common set of questions that every project has to answer, regardless of where it is being built. Not vague promises, numbers. First, how much water will it use? And where will that water come from? And what happens during a drought year? Second, how much electricity will it require? And who pays for the infrastructure needed to deliver it? Third, can the facility reduce its demand when the grid is under stress? If it cannot, does the community end up building new generation and transmission capacity for a single customer? Fourth, whose land is being used and who is affected? That means understanding displacement, compensation, and community impact before construction begins. Fifth, What's next door? A river, an aquifer, a forest, a neighborhood. The physical context matters. 6. What are the public incentives worth relative to the jobs actually created? Because the size of the investment isn't the same thing as the value of the deal for the community. 7. Who checks the commitments and how often? Because a promise that nobody measures isn't really a promise. And 8. What happens if the facility closes? Who owns the infrastructure? Who pays for remediation and cleanup? 8 questions. None of them are particularly clever, but together they create something we don't have consistently today. A shared contract between AI infrastructure and the communities that host it. And importantly, this shouldn't become a completely different contract in every country. The thresholds can be local, the water constraints can be local, the grid conditions can be local. But the questions should be shared because that gives governments a common language, gives communities something they can compare, and gives operators a predictable framework for building. Most importantly, it moves accountability to where it belongs before the shovel goes into the ground. And that's important because we're becoming better at sustainability reporting. Companies can tell us how much energy they consumed, how much water they used, and how much carbon they emitted. That's useful. But imagine discovering those numbers 2 years after the land was cleared and the facility was already operational. The information may be transparent, but the decision has already been made. So, for AI infrastructure, we need to move the question earlier, not just what did you consume, but what will you consume before we approve the project? And that distinction becomes even more important with agentic AI because agentic systems can change the nature of the workload itself. We're moving from software that simply responds to requests toward systems that can operate toward goals. They can reason, act, retry, delegate, and continue. So the question isn't simply how much energy one inference consumes. It's what happens when intelligence becomes persistent, autonomous, and massively scaled. That means efficiency can't remain something we optimize after the system is built. It has to become part of the design. And we also need to move away from sustainability promises made with adjectives. Advanced cooling, water efficient infrastructure, renewable powered AI. These sound good, but they don't tell a community enough. How many liters? How many megawatt hours? What percentage of demand can actually be reduced? What happens during peak demand? What happens during drought? Numbers make commitments measurable, and measurable commitments can be compared. And what can be compared can eventually become a standard. There is one more piece: consequences. A commitment without accountability is just a statement. If an operator promises to stay below a certain water threshold, what happens if it doesn't? If it promises to reduce demand during grid stress, does it actually do it? If public incentives are based on jobs or investment, what happens when those commitments aren't met? The goal isn't punishment, it's making the promise real. And this is why I think the shared 8 question contract matters. It isn't about putting another layer of bureaucracy between companies and construction, it's about creating predictability before construction. Because without a common framework, every jurisdiction will eventually create its own. And if every country creates a completely different set of requirements, companies will naturally look for the easiest place to build. That creates a race to the bottom. And the communities with the fewest resources to push back could end up carrying the greatest burden. Instead, we need a common framework that asks the same fundamental questions everywhere while allowing local communities and regulators to set their own thresholds because the knowledge already exists. Operators understand their cooling systems. Utilities understand the grid, hydrologists understand water, communities understand their local constraints, governments understand their economic priorities. What's missing is a common place to bring all of that knowledge together before the decision is made. And this brings us back to Agentic AI. We call it the future of intelligent systems. Systems that reason, act, collaborate, and operate continuously. But intelligence doesn't exist in the abstract. It runs on chips, inside servers, inside data centers, across networks, using electricity, using water, occupying land, and interacting with the communities that host it. So perhaps the next stage of responsible agentic AI isn't simply about making agents smarter. It's about making the entire system more efficient, measurable, and accountable. Because the future of intelligence needs a physical contract, a contract between compute and the grid, between data centers and water systems, between technology companies and communities. And that contract can start with 8 simple questions. How much? Those questions don't stop AI from being built, they help us build it responsibly. And there's an interesting irony here. We often think the scarce resources for AI, chips, electricity, or water. But by 2030, one of the hardest things to obtain may simply be a yes, a community saying yes, a regulator saying yes, a utility saying yes, a government saying yes. And the fastest way to get that yes isn't to make the sustainability questions disappear. It's to answer them early. Put the numbers on the table, make them measurable, make someone accountable. Because the future of agentic AI isn't going to be determined only by how intelligent our systems become. It will also be determined by whether the physical world has the capacity and the willingness to host that intelligence. So the question isn't just what can AI do? It's also what does it take to make that intelligence possible? I'm Navveen Balani, and this has been Agentic AI, the future of intelligent systems.